This video I am going to explain all the theorems on triangles for the year 24-25 board exams in one video. Please like, share and subscribe my channel. Basic proportionality theorem, which is also known as Thales theorem. The statement of basic proportionality theorem is if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Here, what has been given? A triangle. Now let us have a triangle ABC. So given is triangle ABC. A line is drawn parallel to one side of the triangle. Let the side be BC. Now let us draw a parallel line to BC. The parallel line is D and E. So it cuts AB at D, see the figure, and AC at E. So now DE is parallel to BC. What is to prove? The other two sides means AB and AC are divided in the same ratio, means AD by DB. So to prove AD by DB is equal to AE by EC. If you write like AD by DB is equal to EC by AE, it will become wrong. Okay, now to prove AD by DB is equal to AE by EC, observe that AD is this one by DB is equal to AE by EC. How can we prove this one? We can observe that AD, DB, AE, EC can be the base of the triangles. Now, by using base and height, means we have to construct base and height, two triangles. Okay, we can find areas of triangles. Area is half into base into height. Okay. Now with the base AD, which triangle is there? ADE. Okay. Now no worry. With the base DB, we have to construct a triangle. Which triangle? DBE. So now we have to join the points D and E. So join BE, because now we have two triangles ADE and BDE. We can take the ratios of these two triangles to get AD by DB. I'll explain it later. Just concentrate on this one. Now once again look at the figure. We have two triangles now. With the base AE, which triangle is there? Triangle AED. Okay. With the base EC, this triangle is not the one. EBC is not the one. With the base DE and EC. DE and EC should be the two sides of the triangle. So this triangle is CDE. So now join the points C and D. Okay, now we have triangle ADE and triangle CDE. Now what we have to do in triangle ADE and triangle BDE, if you want to take the areas of these two triangles, we have to draw perpendicular. Perpendicular should always be drawn from the opposite vertex to the base. Here base is AD. This triangle also BDE also has the same, can have the same perpendicular. So now we have to draw perpendicular from the opposite vertex. Opposite vertex to AD is E. So from E, drop a perpendicular to AB. This perpendicular serves as height for both the triangles. So now what will you do? Draw EF perpendicular to AB. Similarly, you can have perpendiculars to the triangles AED and CBE. For AE, the opposite vertex is D. So from D, drop a perpendicular. Which perpendicular? DC. So now draw not DC, DG. So now draw DG perpendicular to AC. Now what will you do? So now we have all the construction parts. Okay. I hope you have understood this concept. Now we have to take the area of the triangles and the areas of ratios of the triangles. You know that area of triangle is half into base into height. In two triangles ADE and ABE, let us take the ratio. Ratio of area of triangle ADE upon area of triangle BDE. Now let us take the area of the triangle ADE. Half into, what is that? Half into base is AD, height is EF upon area of triangle BDE. Here half into base is BD. Look at the figure, you will understand. Height is EF. Here half and half get cancels. Half and half get cancels. EF and EF. So area of triangle ADE upon area of triangle BDE is equal to AD upon BD. Let this be equation number 1. Now let us have the triangles with the base AE and CE. For these two triangles, the perpendicular is DG. So now let us take the ratios of areas of AED and DEC. Area of triangle ADE is half into base. Now the base is AE into height is DG upon area of triangle CDE. Base is CE, so half into CE into height is DG. Here half and half get cancels. DG and DG get cancels. So area of triangle ADE upon area of triangle CDE is equal to AE upon CE. Let this be equation number 2. You may feel happy. You got the ratio. AD by DB is equal to AE by EC. But still now LHS are not equal. You have to one thing. Isn't it? Numerator and numerator are equal, but the denominators are different. So one more step we have got now. Here observe the triangles BDE and CDE. They stand on the same base DE and between the same parallels DE and BC. So now areas of triangles BDE and CDE are same. Okay. Since triangle BDE and CDE lie between the same parallel DE and BC and on the same base DE, area of triangle BDE is equal to area of triangle DEC. Let this be equation number 3. Now we have all the 3 equations. Here observe that area of triangle BDE and area of triangle CDE are one and the same from the equation 3, isn't it? So now let us replace this one as area of triangle CDE. Okay. So CDE into area of triangle BDE. Now area of triangle ADE by area of triangle BDE is equal to AE by CE. So LHS and LHS are equal. So RHS should be equal. So now we have AD divided by DB is equal to AE by EC, isn't it? Hence proved. Now let us have a look into converse of basic proportionality theorem, the statement of which is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. What has been given now? Triangle ABC and a line DE cuts other two sides, means AB at D and AC at E. In the same ratio, means AD divided by DB is equal to AE divided by EC. What is to prove? The line is parallel to the third side. It is third side now. Line is parallel to the third side. Okay. Now, in basic proportionality, we are given that what? DE is parallel to BC. We have to prove AD by DB is equal to AE by EC. But in this case, we are given AD by DB is equal to AE by EC. To prove DE is parallel to BC. This is simple theorem. You can learn it very easily. The first one is bit difficult. It carries 4 marks. The first one. It may carry 2 or 3 marks. Okay. Construction. Now draw a line DF parallel to BC like this. Now proof. Here we don't know DE is parallel to BC, so now we have drawn DF parallel to BC. Because we have drawn DF parallel to BC, what happens now according to BPT? AD by DB is equal to AF by FC. Why? Because of basic proportionality theorem. We are given that AD by DB is equal to AE by EC. We are given because you can write it in the bracket, otherwise you will get confused. Here observe RHS, they are LHS, so RHS should be equal. So RHS means AE by EC is equal to what? AF by FC. Here we have to prove that here AE by EC is equal to AF by FC. Again and again you have to see the figure and also the text, and also you have to listen also, then you will understand the problem. Now we have to prove that F and E one at the same. So remember this step very much. Okay. you have to add 1 to both sides. Only because in the numerator you have to get AC, that's all. Here in the denominator we have to get EC and FC, that's all. So we have to add. Here LCM is EC. So in the numerator you will have AE plus EC by EC in the denominator is equal to, here LCM is FC, AF plus FC upon FC. You might have now understood. AE plus EC. What is it AC? In the next step I will explain. Okay. Here AE plus EC is equal to AC. So in the numerator AC, in the denominator EC. AC by EC, here AF plus FC is equal to AC. So in RHS, AC by FC. I have already told in the denominator you should get EC and FC. So we have added 1. Here AC in the numerator get cancels. So now we have 1 by EC is equal to 1 by FC. Now let us take the reciprocals of both LHS and RHS. What is it? EC is equal to FC. Observe the figure. Okay. EC is equal to FC. How can it be? FC is longer, isn't it, in the figure? EC is shorter. So our imagination may be something we have imagined, not exact thing, isn't it? So EC is equal to FC. How can it be? Now let us drag the line on DF line on D. What happens now? Okay. E and F are one and the same. Means E and F coincide on the same point E. We can consider the F point as E now. Now we have constructed that DF is parallel to BC. Now DF is not there. This was DF now. Okay. Because we have constructed. So instead of F we can write E. So DE is parallel to BC. This is what we are needed to prove. Hence proved. Two triangles are similar if their corresponding angles are equal and their corresponding sides are in the same ratio, means they are proportion. If one angle of a triangle is equal to one angle of another triangle and the sides including these angles are in the same ratio, means proportional. Respectively, 3 theorems are there. Now let us learn them one by one. A criterion of similarity. The statement of this is, if in two triangles corresponding sides angles are equal, then their corresponding sides are in the same ratio or proportion, and hence the two triangles are similar. The question may be asked like this: prove that if in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio or proportion, then the two triangles are similar. The question carries 4 marks, very important question. So please learn this thoroughly. What has been given? in two triangles. So now let us have two triangles. I have already sketched them. Triangle ABC and triangle DEF. Okay. Such that corresponding angles are equal. Means angle A is equal to angle D. Angle B is equal to angle E. Angle C is equal to angle F. Please look at the figure also while learning. While proving theorem, you have to always, first you have to write the given items, then to prove. What is to be proved here? AB by DE means corresponding sides are in proportion. The corresponding side of AB is DE, BC is EF, so BC by EF, AC by DF. Construction is there. For all the three theorems there is a construction, same construction. Now we have to cut DP which is equal to AB and DQ which is equal to AC and join PQ. Now name the points as PQ. Now let us prove. In a triangle ABC and triangle DPQ, first let us prove that these two triangles are congruent. Means AB is equal to DP. Why AB is equal to DP? By construction. AC is equal to DQ. Angle A is equal to angle D. Why? It has been already given. Angles of one triangle is equal to angle of another triangle. It is given. And AC is equal to DQ. Why? By construction. So by SAS criteria, similarity, congruency criterion, what can we say? Triangle ABC is congruent to triangle DPQ. We can put triangle DPQ on triangle ABC or triangle ABC on triangle DPQ. Here the corresponding parts are equal. Now we have triangle ABC is congruent to triangle DPQ. Observe the figure. What is the use of proving that two triangles are congruent? The corresponding parts are same. So here angle B is equal to angle P. But corresponding parts of congruent triangles. What is CPCT? Expansion. Corresponding parts of congruent triangles. But we are given that angle B is equal to angle E, isn't it? It is given. Here observe LHS are equal. So RHS should be equal. So angle P is equal to angle E. Observe the figure. Angle P is equal to angle E. Here observe that line PQ, line EF. A line transversal cut these lines. These are the corresponding angles. They are equal. If the corresponding angles are equal, then the lines will be parallel. Observe the figure. So, PQ parallel to EF. So now we have PQ parallel to EF. Observe the figure. We know that if in a triangle a parallel line is drawn to a side of a triangle, here the side is EF, then it cuts other two sides are in the same ratio, isn't it? Yeah, it is BPT. BPT can be also like this. dP by dE is equal to dQ by dF is equal to PQ by EF. This is also BPT. I am writing the ratio, but there is a problem. We haven't proved this theorem yet, isn't it? We have to prove the result. So we only know that dP by PE is equal to dQ by QF. Observe the figure. I am highlighting that one. Now we have dP by PE is equal to dQ by QF. Why? Because of BPT. I have earlier said one ratio, isn't it? dP by dE is equal to dQ by dF. Observe the figure. In order to get this result, we have to take the reciprocal of both LHS and RHS. What is the reciprocal of this one? PE by dP. The reciprocal of this one is QF by dQ. In order to get the result, that is dP by dE, we have to add what? 1 to both LHS and RHS. See, here in the numerator you will get what? PE plus dP. PE plus dP. Because LCM is dP, here in the numerator you will get QF plus dQ upon dQ because LCM is dQ. Now we have PE, observe the figure, PE plus dP. What is it? dE in the numerator. So this part becomes dE by dP. Here in RHS, QF plus dQ, observe the figure. What is it? dF. So that is equal to dF by dQ. So instead of dP, we can put AB. We have by construction we know it. Instead of dQ, we can put AC. So now we have proved dE upon AB is equal to dF upon AC. Similarly, we can prove EF upon BC. So, half done our work. We can stop here also, but half done. How? I will show this part. Now, I will cut the triangle like this. AB is equal to EP, BC is equal to EQ. Now we have triangle PEQ. Those are similar. So now we can have the ratio in this triangle. How? dP by PE, the same ratio that we have written earlier. dP by PE is equal to here QF by EQ. Look at the figure now and then and write. Then add 1 to both LHS and RHS. Here LCM is PE, then in the numerator dP plus PE upon PE is equal to here LCM is EQ, QF plus EQ upon EQ. Here what will you have? Observe. dp plus p. What is it? de. This is de by pe is equal to here qf plus eq. What is it? ef by eq. So here instead of PE we can write AB, isn't it? Instead of PE we can write AB. DE by AB. This ratio we have got earlier also in the previous slide. Here instead of EQ we can write BC. So instead of EQ, you can write what? BC. EF by EQ. This is the result we wanted to get, isn't it? Instead of EQ, you can write what? BC. So DE by AB is equal to EF by AB. So now we have what? AB by DE is equal to BC by EF. That one I have written in hand in the previous slide. You need not do this one, that one. So I have written. Okay. Similarly, we can prove that BC by EF. Okay, you can finish there only, and you can write like this. Then AB by DE is equal to BC by EF is equal to AC by DF. So triangle ABC is similar to triangle DEF. Corresponding sides are proportional. Hence proved. Now let us prove SSS criterion of similarity. What is the statement of it? The side criterion for similarity of two triangles state that if in two triangles sides of one triangle are proportional to the sides of other triangle, then their corresponding angles are equal and hence the two triangles are similar. The same statement may be asked like this in question form. Prove that if in two triangles sides of one triangle are proportional to the sides of other triangle, then the corresponding angles are equal and hence the two triangles are similar. What has been given now? Two triangles. Let the triangles be ABC and DEF. The sides of one triangle proportional to the sides of other triangle means AB by DE is equal to, observe the figure, BC by EF is equal to AC by DF. Now to prove, angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F, and hence the triangles are similar, means ABC is similar to triangle DEF. Now let us do some construction as the previous theorem. What to do? Cut DP is equal to AB. This is the point P. and DQ is equal to AC. These points are Q and P and Q join PQ. Now we are given what? AB by DE is equal to AC by DF. Take only these two sides. And by construction we know that AB is equal to what? DP. So replace AB by DP. AB is equal to DP by construction and AC is equal to DQ by construction. So now replace AB by DP. So this becomes dP by dE. AC by dQ. So this becomes dQ by dF. Now take reciprocals because here we want this. Now this triangle is main. We want dP by PE ratio and dQ by QF. So in the numerator we should have dE. In the denominator dP. So dE by dP is equal to dF by dQ. Now we have taken the reciprocal. We have dE by dP is equal to dF by dQ. Actually we want dP by P, dQ by QF. So please remember this step, subtracting 1 from both LHS and RHS. What will you get? dE by dP minus 1. In RHS also minus 1. Here LCM is dP. So in the numerator dE minus dP by dP. Here LHS is dQ. So dF minus dQ by dQ. So dE minus dP means what? dE minus dP. That is PE. PE by dP is equal to here QF by dQ. Now once again we have to take reciprocal because we want dP by P is equal to dQ by QF. So now we have dP by PE is equal to dQ by QF. Observe the figure. If you see this one, what will you observe? If dP by dE is equal to dQ by QF and a line, this line PQ divides these two sides in the same ratio, then the line is parallel to this side, third side. What is this theorem known as? It is Converse of basic proportionality theorem, which states that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Hence, PQ is parallel to EF. So, now we have angle P is equal to angle E. Why? Corresponding angles. These two lines are parallel and corresponding angles are equal. Similarly, angle Q is equal to angle F because they are corresponding angles. So now we have angle P is equal to angle E, angle Q is equal to angle F. Angle P belongs to the triangle DPQ and angle E and angle F belongs to the triangle DEF. So in triangle DPQ and triangle DEF, we have to prove that they are similar, and we have to write their corresponding sides. Um, we have learned that if two triangles are similar, then their corresponding sides are in proportion in the previous theorem. So here they are similar. We have to prove. We have already proved, but once again I am writing here angle E, angle Q is equal to angle F from equation number 2. So triangle DPQ is similar to triangle DEF by AA similarity criterion. So now we can write their corresponding sides are in proportion, isn't it? Ratio of their corresponding sides. So let us now write the ratio of their corresponding sides. dP by dE is equal to dQ by dF is equal to PQ by EF. In the next step, you can observe that by proving what DPQ and ABC are similar, we can say that angle B and angle E, angle C and angle F, angle A and angle D are equal in the next step. So I am getting ready for proving that thing. Why these corresponding sides are equal? Let us name this as equation number 3. Corresponding sides of the similar triangles are in proportion. So I have written like that. Now we have already given that AB by DE is equal to DE, BC by EF is equal to AC by DF. Let this be equation number 4. Why this ratio is correct? It has been given, so I have written like that. But observe that we have constructed dP which is equal to AB, dQ which is equal to AC. By construction it is true. So now I can replace this AB by dP and this AC by dQ in the next step. So dP by dE, let us retain this one. BC by EF is equal to AC by, not AC, I am replacing AC by dQ. Let this be equation number 5. Here observe this and this are equal, isn't it? And again this and this. Not this one. Sorry, not this one. This and dQ by dF equal. Then this one I am putting rectangle here, and this one must be equal, isn't it? So BC by EF is equal to PQ by EF. Here EF and EF get cancels, isn't it? So numerator should be equal to each other. BC is equal to PQ. BC is equal to PQ. I think now you have got my idea that I am proving triangle ABC and triangle DPQ are congruent. AB is equal to DP by construction, AC is equal to DQ by construction, and now we have proved BC is equal to PQ. Let this be equation number 6. BC is equal to PQ. Now I have already told that I have to prove triangle ABC and triangle DPQ are congruent. So in triangle ABC and triangle DPQ, what? Which sides are equal? AB is equal to DP by construction. AC is equal to DQ by construction. BC is equal to PQ. Why? Just now we have proved this one from 6. It implies that triangle ABC is congruent to triangle DPQ by SSS criterion of congruency. Now we have proved that triangle ABC is congruent to triangle DPQ, isn't it? Observe the figure also. It implies that angle B is equal to angle P, isn't it? Corresponding parts of congruent triangles. Similarly, angle C is equal to angle Q. But before that, observe, angle P is equal to angle Q. We have proved this one, isn't it? Angle E is equal to angle P. So, here observe RHS and RHS are equal. So, LHS should be equal to one another. Angle B is equal to angle E. Angle B is equal to angle E. Similarly, we can prove that angle C is equal to angle F. How? Angle C is equal to angle Q, corresponding parts of congruent triangles, but angle Q is equal to angle F. We have proved earlier, isn't it? Angle F is equal to angle Q. So here LHS, RHS and RHS are equal. So LHS should be equal to each other. Angle C is equal to angle F. Now in triangle ABC and DEF, final part. ABC and triangle DEF, we have what? Angle B is equal to angle E. We have proved it. Angle C is equal to angle F. So triangle ABC is similar to triangle DEF. Why? Because of a similarity criterion. Hence proved. SAS criterion of similarity. What does it states? If one angle of a triangle is equal to one angle of other triangle and the sides including these angles are proportional, then prove that the two triangles are similar. This is the question. Very important question. It has also been appeared in model question paper, which is issued by the board, which carries 4 marks. Now, what has been given? Here two triangles. You can sense, isn't it? There are two triangles, ABC and DEF, such that angle A, one angle is equal to another. Angle A is equal to angle D, and the sides including these angle, side AB and AC, which includes angle A, here DE and DF, which includes angle D, are proportional. Means AB by DE is equal to AC by DF. This is given. To prove, in all theorems, the second step is to prove. What is to prove? Triangle ABC is similar to triangle DEF. We have to do construction, which is similar to all the three theorems. Draw P and Q on DE and DF such that DP is equal to AB and DQ is equal to AC. Join these lines P, Q. Now we have to prove that triangle ABC and triangle DPQ are congruent. So in triangle ABC and triangle DPQ, what are in common? Side AB is equal to side DP. Why? By construction. Angle A is equal to angle D. Why? It is given. Look at the figure. AC is equal to DQ. Why? By construction. Now we can say that by side angle side congruency rule, triangle ABC is congruent to triangle DPQ. Why? By SAS criterion of congruence. Now let us prove. We are given that AB by DE is equal to AC by DF. Now we can substitute, instead of AB we can substitute DP, isn't it? Instead of AC we can substitute DQ. So now DP by DE is equal to DQ by DF. Why? By construction. Now let us take the reciprocal of both LHS and RHS. What we get? dE by dP is equal to dF by dQ. Now let us add 1 to both LHS and RHS. Subtract 1 from both LHS and RHS. Since we need to get here dE minus dP. What will you get? PE. Here we have to get QF. So we have to subtract. So here LCM is dP. So in the numerator dE minus dP by dP. Here LCM is dQ. So dF minus dQ by dQ. Once again observe the figure. dE minus dP. What do you get? PE. So LHS is PE minus dP. RHS is QF minus dQ. So now we have PE upon dP is equal to QF upon dQ. Observe the figure. Now let us take the reciprocal. What will you get? dP by PE is equal to dQ by QF. Here what do you observe? Yeah, it is converse of basic proportionality theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. By converse of BPT, if a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. Hence, PQ is parallel to EF. So now we have PQ parallel to what? EF. So it implies that angle P is equal to angle E, isn't it? Why? Corresponding angles. Angle Q is equal to angle F. Why? They are also corresponding angles. Angle P is also is equal to angle B. Why? Corresponding parts of congruent triangles. Here LHS and LHS are equal, so RHS should be equal. So angle E is equal to angle B, or angle B is equal to angle E, one at the same. Angle B and angle E are equal. Here angle Q is equal to angle F, but angle C is equal to angle F, isn't it? So angle Q is equal to angle C. Here also LHS and LHS are equal. So RHS and RHS should be equal. So angle C is equal to angle F. So in triangle ABC and triangle DEF, what do we have? Angle B is equal to angle E and angle C is equal to angle F. Angle A is equal to angle D. It has already been given. So triangle ABC is similar to triangle DEF. Why? Angle similarity criterion. If you want, you can add this one also, criterion. Hence proved. I hope you have understood all the three theorems very neatly. If you have any doubts, please put your doubts in the comment box. Please like, share and subscribe.